Okay, class, I just wanted to go over what's going to be on your final exam, specifically things that aren't on the review test. Alright, so since it's something that you're going to be taking at home, there's no definitions or stating theorems. Now, that said, there are some problems, like the true-false example, where you'll have to actually know the definitions in order to get the answer, or to show if it's true or false. The tank problem. There is a tank problem, but it's not like the number 4 on the sample final exam. It's more like the tank problem in the DE Laplace folder. If you look at the mixing Laplace problem that I scanned in, it's going to be more like that. So it's going to be a mixture of a tank and a Heaviside problem. The one question I didn't see on your sample exam that I definitely am going to put on this is a form of YP second order using the method of undetermined coefficients. And once again, for that, you need to find the homogeneous solution in order to verify that things are linearly independent. And the last thing, which I've got another little sheet of paper I can go over with you here, proofs. The proofs are all going to be second order proofs that you were responsible for on test number 2. That's not saying I'm going to ask every single one of these, but the ones I will ask will be in this list. Okay, and specifically here I'll say proof type problems. So let me just go over the things you'll need to be able to do. Show 2 solutions are linearly independent, basically showing that the Wronskian can never be 0. Remember, never, meaning if it's 0 at one point, that's bad. Show if e to the RT is a solution to star to the second order homogeneous equation, if R is a solution to the characteristic equation a lambda squared plus b lambda plus c equals 0. Also, you should be able to show that t e to the RT is a solution when R is a double root. I wouldn't say either one of those two are really proofs, but the rest of them are. So you should be able to show that a linear combination of solutions is a solution. That is that C1 Y1 plus C2 Y2 is a solution when Y1 and Y2 are solutions. A lot of you got that confused on the second test with the superposition principle. So those are 2 different things. Okay, number 4 here, show that if, and I didn't write it here, but I'll say it, if Z of t, which is represented by U of t plus IV of t, is a solution to star, then U and V are both real valued solutions to star. Okay, so that's one. The representation for second order non-homogeneous differential equations, not the one where you had to look at all the cases on the Wronskian when it's Z equal to 0 and all that good stuff. So this one's the short one. You just, you use the superposition principle in the first step, and then you move things around and invoke the existence and uniqueness theorem, and that's pretty much it. And the last one is the superposition principle, and I'll state what that says. It says that if f of x is a solution, if y of t is a solution to ay double prime plus by prime plus cy equals f of t, and y2 is a solution, let's say, well, that's y1. y2 is a solution to ay double prime plus by prime plus cy equals g of t, then y1 plus y2 is a solution to ay double prime plus by prime plus cy equals f of t plus g of t. Alright, that's everything. So get your studying done. If you have any questions, send me an email.